Okay, so we're going to do a little proof where we use the perpendicular bisector as one of the main tools for proving two triangles congruent. Now, perpendicular bisector is basically just two different things. The whole thing about a perpendicular bisector is that you get two pieces of information. So a perpendicular means if a line or line segment is perpendicular to another line or line segment, that means they form 90-degree angles. Okay, perpendicular means right, 90 degrees. And bisector refers to dividing something in half. So whenever you look at a bisector, you ask yourself what it is you're dividing in half. So here's a situation where we have some given information. Our given information is that we have LO, which is this line segment, this side, and it is a perpendicular bisector to KS. So you pay attention to what it's bisecting and what it's perpendicular to. So this side right here is perpendicular to KS. So KS starts at K, goes to S, and it's down here at the bottom. So these two are the things that form a perpendicular bisector. So all we're going to do is we're going to start out the same way we did before. We're going to copy down the given information. And I'm running out of space, so I'm going to use a second row here. LO is a perpendicular bisector to KS. And I'll put the given down here, and hopefully that way I won't make a mistake and write the given here. So this is one statement right here. LO is a perpendicular bisector to KS. So what we know about that, there isn't any other given information. So it doesn't tell us anything else about this triangle. And remember, we're looking for side, 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 angle, side, angle, side, angle, 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 side, which could also be side, angle, angle. And then HL would work also for 90-degree, or a right triangle. This, because of the perpendicular, is going to be a right triangle, so this is a possibility. So we have to look at this and ask ourselves, what can we use in order to find the other pieces, the missing pieces? When you look at this picture, this diagram, notice there is a line segment that goes right down the middle of this larger triangle, and it divides it up into two triangles, one on the left, one on the right. This particular side right here is part of both triangles. So we look at this triangle on the left. Okay, we have side KL, side KO, and then this side is KO. When we go over to this triangle, this shares the same exact side, and it would be KO also. So that's one thing that you want to keep in mind, and you should notice that right at the beginning, even before you start the proof, that you might be able to use the reflexive property, because that's what that is. When you have two things that are equal to themselves numerically, like 6 equals 6, for instance, that's the reflexive property of equality. When we're talking about congruence, it's the reflexive property of congruence. So in this case, we have LO, which is the side we're using on this one, and it's congruent to LO, which is the side we're using for this triangle. So it's congruent to itself. That's what the reflexive property says. So the order doesn't really matter too much as far as what we write down, as long as we get everything taken care of. So I'm going to go ahead and, since we have that here, I'm going to go ahead and mark it. Left side, right side, you only have to mark it once in the middle. I mean, I made double tick marks. You can use single, it doesn't matter. So we have LO, congruent to LO, and the reason for that is the reflexive property. Okay? Now, that leaves us still with a problem, because if we're using the right triangle, like this is going to be a right triangle, we have a leg, right? That's where the right angle is going to be. Or we have a side, a single side. We need another angle or the hypotenuse, depending on what information is given. So we're going to go back up to this. And like I said, there are two pieces of information. Let's start with this one first. We've got, well, perpendicular bisector. So the key here is perpendicular. This side is perpendicular to that side. That makes that a 90-degree angle and that a 90-degree angle. Okay? So, and then also the bisector, LO, is going to divide this side right here in half. That means the left side is congruent to the right side. So we can mark it. Now I wanted to get this part taken care of first, because I want to understand what I'm going to be able to use. Am I going to be able to use hypotenuse leg? Now remember, hypotenuse leg needs the hypotenuse, and this side right here is the hypotenuse. But we don't know anything about these two sides being congruent. There's nothing up here that helps us with that. Perpendicular bisector, the bisector tells us about these. So what we have is two legs, a leg and another leg. But we're not using a triangle congruent with leg. So instead, we have a side, and then that 90-degree angle is an angle. So we have side, angle, side. So that's what we're going to be able to use. We're going to be able to use side, angle, side. So what I want to say is this angle right here, KOL, and this angle, SOL, we want to compare them. Well, we know they're both 90-degree angles, and so that, by definition, those two are going to be congruent. So we could say angle KOL is congruent to angle SOL. And so all I'm going to do is write the definition of right angles, or I'm just going to put perpendicular. Okay, so it's perpendicular. What's that mean? It means we form two 90-degree angles that are congruent. And so that's what we have here. The next step is to take care of the sides. So first I did the perpendicular. You can change the order, it doesn't matter. But first I did perpendicular. Now we're going to do the bisector. So that makes KO congruent to OS. And the reason we know that's true is because of what we know about bisector. A bisector cuts the side, or cuts things in half. So in this case, we're cutting the side in half. And if something is cut in half, the two parts have to be equal. So that's the definition of a bisector. Okay, so now we have a side, angle, side marked up here, and we have a side, we have an angle, and a side written down here. That's enough. We have triangle KLO congruent to triangle SLO. Now I do want to make sure I warn you a little bit. I wrote this down here, and it just happened to come out in the correct order, SAS, but do not use the order you have written these down for your triangle congruence theorem. Get that from the picture, because sometimes if you write it down in the wrong order, it will come out something like SSA or ASS. So you have to be careful to make sure you use the diagram to help you with the triangle congruence theorem, and not the order you wrote it down here. This is just coincidental. It's a coincidence that we got this to say.